Good morning, everybody. Thanks for joining us today. Today's webinar is on solving cybersecurity for building management systems. Our speakers today are Michael Dugent, our IoT Director at Nozomi Networks, and Darryl Benson, VP of Development and Managed Service at Intelligent Buildings. Mike, I'll leave the floor to you.
That sounds great. Let me share my screen. Welcome, everybody. I guess we can start with Darryl. Do you want to do a quick introduction of yourself for the group here?
Sure. Thank you, Mike. So my name is Darryl Benson, as Sarah mentioned, and work for a company called Intelligent Buildings. We're an MSSP partner of Nozomi's, and our Intelligent Buildings is a services company that focuses on the real estate market, and we really work on solving cyber and operational issues within commercial real estate. So thanks for the opportunity to speak together.
Perfect. Thank you, Darryl. And then, myself, Michael Dugent. I'm the IoT Director for Nozomi Networks, focused on business development in verticals outside of the core operational technology space, of which real estate and some of the underlying verticals associated with real estate are a part of. So what we're going to do today is have a quick overview of some of the security challenges facing building management systems and smart buildings in general, focused on not just on the building management systems themselves, but also the IoT systems that are related to that. Look at some use cases for some challenges that we've seen in some of the projects that we've done in this space. And then we'll also look at a case study of a project that Nozomi Networks has done in a big real estate environment, covering smart buildings and smart campus technology. I think we have it set up so that there is a Q&A page. If you have questions as we go through the presentation, feel free to drop it into that Q&A section. And we will try to cover those questions as we go through. As long as I see them, I'll make sure that they get in there. And I don't know if that also will function in the chat component as well. But if you drop them in the Q&A question, we'll try to cover them as we go through the presentation. And it will be recorded, and you'll have the option to have access to it after we're finished. Great. So let's start off with looking at some of the industry challenges facing smart buildings and real estate types of environments. I think what we're facing right now is that there is a massive digitalization process that is going on in just about any number of industries, actually. If you've been on some of the webinars that we've done for other verticals in the past, you've probably heard me say this story before, but I'll do it again now anyway. One of the ways that I relate to what CISOs and security teams are dealing with as we go through this digitalization process is just to think about the digitalization that's happened in my own home. I look at, maybe 10, 15 years ago, I had 5 or 10 IP addresses, a couple of workstations, the printers, the routers. There really wasn't a lot more than that. And I look across the apartment today, and I've got, connected televisions, video game systems. The kids have their, handheld devices. The front door has a CCTV camera type system that's connected to the network. The doorbell system's connected to the network. The thermostats are connected to the network. There's lighting systems that can be connected. And it gets a lot more advanced than that. You see refrigerators and even toasters that are connected to the internet now. And it's pretty intense when you think about going from that 5 or 10 devices to, dozens or even potentially hundreds of devices. And, that type of exponential increase in connectivity and connected devices is something that every organization is dealing with across the world, airports and manufacturers, and, definitely smart buildings and building environments. So what happens with that digitalization is that you have a lot of fantastic capability that is available to those of you that are operating those buildings, or your customers or the tenants and occupants of those buildings, but it also creates a cybersecurity risk. The attack surface that the security team needs to deal with is exponentially growing as well. And there's complications in the fact that these aren't typically standard operating systems. These aren't using standard communication mechanisms. All of the things the security teams have a comfort level with when it comes to cybersecurity functionality kind of goes out the window a little bit when you start looking at a lot of these unique devices and looking at the digitalization of the operational technology environments associated with the building management systems. So there's a lot of potential things there, right? So the building management systems, building management components, are inclusive of a lot of different environments and a lot of different functionalities. You're looking at things like physical security and access control. You're looking at what we say vertical transportation, so all of the elevators and the escalators, heating, cooling, lighting. All of this is potentially susceptible to cyber attack, and those cyber attacks may not even be specifically targeting those systems and trying to shut the lights off or shut the power off. They could be used just as pivot points or points to set up a presence in an organization that they plan to target for something later. So there's a lot of potential risk there, especially because most organizations just aren't looking at these environments from a cybersecurity perspective. They tend to get missed. A lot of the companies that we've worked with for proof of concepts, for initial projects, we see that the cybersecurity programs typically only covering 30 or 40% of the overall attack surface. A lot of this building management infrastructure, the IoT devices connected to this tend to get missed. And, that's typically one of the early wins when we start those projects, is just to get a visibility on all of those additional connected devices.
If I could add, Michael, sorry, if I could add the one area to focus on, you have it in your slide, is that the number of people touching the different systems within the building is surprisingly large in typical real estate, between the different vendors for the different systems, the property management teams, multiple people are accessing these systems with usually untrusted devices from untrusted networks. And what that introduces is, as he's already mentioned, is the risk to those systems that we've introduced, not only just different points of connectivity and to traverse east and west, but points of departure from the network to reach out to really bad actor websites and produce malware attacks. So we've actually caught that and we can talk about this later in the slides when we talk about architectures a little bit, but we've actually caught that with Nozomi within our managed service, that we've seen bad actors, systems reaching out to bad actors, so we could then react and block that threat surface from manifesting within the network.
Perfect. Thanks, Darryl. And I think what I'd like to stress too is these aren't hypothetical things that we're talking about. There are specific examples out there, and some of which, had pretty significant media attention. I think one example a lot of people are familiar with is an example where attackers use the fish tank thermometer as an entry point to gain access to a cyber network of a casino, and actually pull the high roller database across the network and out of the thermostat back into their cloud, compromising a lot of personal and financial data about the most important customers of that casino. And this goes back to my point, a lot of these IoT devices, of which a fish tank thermometer is probably one not a lot of people in the security team at that casino are thinking about, they're stripped down. There's limited capabilities of the operating system. Authentication, encryption, things like that are typically missed, just as they are in many OT devices. And the security controls around those are probably an afterthought to just making sure that it's doing the function that it is supposed to be doing. In that case, just keeping the water at a reasonable temperature for the occupants there. We saw another example where hackers were able to get access to over 150,000 Verkada video surveillance systems, and most of those were kind of set up in a lot of different places. We have some examples there: Tesla factories, Cloudflare's offices, more in like a botnet type of, potential type of attack. Now, this wasn't malicious. This was more of a research type of hack, just meant, hoping to show that how commonplace there's security flaws in this type of infrastructure. But we think about the power, turning all of that into a big botnet could potentially have, or using those as pivoting into, some really important organizations there. They could be that point of presence or that pivot point, as I talked about. There's a lot of potential risk there. So these, just as some examples, these are, things that are actually people are dealing with, and that there's actual consequences out there in the real world right now. These aren't hypothetical things that we're talking about. And I think so that brings us to the overarching message, which is that these connected devices are everywhere. And it is critical to understand the entire attack surface that you're dealing with if you're responsible for cybersecurity of any type of building environment or building campus environment. So let's start to dig in a little bit and look at some of the specific examples. So we're going to look here at the, just some examples of the potential attack surface just at a generic building. So a generic smart building, generic real estate. You have first what we would say are the OT components, the building automation system. The building automation system is going to be inclusive of power. It's going to be inclusive of, I mentioned the vertical transportation, so elevators, escalators, lighting control systems, HVAC, so the heating and cooling systems, all of the energy management, CCTV and NDR, access control. A lot of that goes into the physical security components. And these are actual operational technology systems. And it's important when you start to look at these from a cybersecurity perspective to have to an understanding that most of the IT cybersecurity tools and IT cybersecurity programs that are typically going to be in place aren't going to have a capability to understand how to prevent attacks or make identification within these operational technology environments. These are PLCs. These are vendors that are using specific protocols for these environments. Typically in buildings, we're going to see things like BACnet. The Nozomi Network solution has a both passive and active capability for protocols like BACnet. We may see vendor-specific protocols. This is very different than the typical computer, laptop, server infrastructure that the rest of the organization is dealing with from a cybersecurity perspective. And then when you think about the IoT assets in a building, a lot of these are the bulk of the initial connected devices are in a way related to a lot of the building management functions. So the temperature sensors and thermostats are related to the heating and cooling. You're going to have physical security components like barcode readers, badge access, maybe biometric access that are part of the access control and physical security functionality. A lot of cameras all over the building. The lights themselves that are going back to lighting control and the lighting bridges. A lot of what 15 or 20 years ago would have been completely mechanical devices that you don't have to think about from a cybersecurity perspective. These now connected devices are proliferating pretty significantly in these buildings, and in a lot of ways are connected to the building management systems or the building automation systems. And then it goes a lot beyond that when you start to get into IoT, when you start to think of screens and digital displays. I see a lot of buildings where even the front doors, the automatic doors have controls and they're connected, and they can be put on a schedule. I've seen windows that can be put on a schedule, shades that can be put on a schedule. There's a lot of interesting things there just in the generic building space. We take it from a bit of a different angle and look at this more from a specific vertical perspective. If you have a building operated by a financial institution here, same thing. We have building OT assets. So a lot of the ones we already talked about on the power side and physical security side, the HVAC side. You'll also tend to have more specific things here like fire detection and fire suppression systems. You'll see alarm systems, smart safe environments. A lot of interesting things that are kind of unique to the banking environment. We may get into data centers, and actually I have a slide next where we'll kind of dig into data centers a little deeper because that has its own unique aspect. And then on the IoT side, again, a lot of touch-enabled devices, digital displays and digital signs. Here you've got point of sale terminals, endpoint devices like that. You have ATMs, both on premises and off premises. All of these are connected, interconnected devices that are potentially a part of that overarching attack surface. Darryl, anything to add before I get into the data center side?
No, one of the things I would just add to all of these considerations is doing this at scale across large portfolios. And in this specific vertical example, think about the number of not just bank offices, but bank branches, or in a pure office real estate perspective, how big is anyone's real estate portfolio, or in the enterprise space, how many buildings do you have across your portfolio? So I think across healthcare, office, financial, there's an opportunity to really touch all of these asset classes with different scenarios and different types of assets, and really bridging that the IoT and OT systems and understanding the impact these different asset classes and the systems have on those different asset classes.
Perfect. So as I mentioned, we'll take a bit of a deeper look here specifically at a data center. I know that a lot of the real estate clients that Nozomi Networks is working with today are operating their own data centers, and our financial clients as well tend to be operating their own data centers. And data centers have a really, unique case for us in that there tends to be typically a lot of cybersecurity spend and a lot of cybersecurity interest on data center environments, but a lot of that focus, a significant amount of that focus, tends to be put on the server infrastructure itself, of course, and on the data pipe coming in and out of the facility, especially perimeter defenses and things like that. That's where the vast majority of the cybersecurity focus tends to be. But it's critical to consider the potential impact of a cyber attack on the building components and the physical components. I think there was actually just an example in the news this week where the cooling system at some critical data centers for a financial institution that were hosted in a tropical location were not acting properly, and we had several days where payment processing was not happening for the financial institutions that were utilizing that data center. If the cooling systems are unavailable, data centers are only going to be able to operate for probably minutes, before it heats up to a point where there's critical failures and it's not operating. So you have the potential impact of targeting those systems directly. And then, of course, as I mentioned, you also have the potential impact of these devices can be a part of the critical networks where the servers are located. And if they're not being looked at from a cybersecurity perspective, then you could see them being used as just points to sit and wait and, kind of poke your holes into the rest of the facility, potentially bypassing some of that perimeter defense that you have and the server level defense that you have. We had a study done at one point that found over 20,000 data center infrastructure management tools were accessible directly from the internet. I don't think we extended that to see if there was default credentials or easy to crack credentials used to get in, and log into any of those. But 20,000 plus data center infrastructure management tools directly connected to the internet, and if access to those was capable, then you could potentially see things like the power or the battery backup systems being impacted, or the fire detection or fire suppression systems being initiated and shutting things down, or the cooling systems being impacted. There's a lot of significant amount of potential risk there, and I think this is an area where we're starting to see a lot of attention, again, real estate clients, financial sector clients, and making sure that the physical components of the data center are taken care of from a cybersecurity perspective, along with all of the perimeter and server infrastructure.
And if you extend that same type of study, Mike, out into the different OT systems, we've done the same. As we've looked at, you can look live and see what's out in the wild, and you can see thousands upon thousands of typical OT systems that are exposed directly to the internet. And one other thing I'll mention, we've run into, not in a data center, but with an emergency power generation at a large healthcare provider. We also started looking for cross traffic. So we know that the generator in the back has a controller on it, but it should never be talking to a PDU in the building, or, So if we see, and we can track these things with Nozomi, if we see traffic, once we establish the pattern, if we see traffic that goes outside of a pattern, meaning there might be a man in the middle or somebody physically breached the site somehow and put a device in there, that's another thing to look out for. And even in the best secured environments, if somebody gets in physically, you can then start having abnormal traffic patterns start to appear. So it's another thing to look out for, along with all those different exposed devices.
So I think we started talking about some of these already, but just to take this a bit further, just some of the example use cases. These are the things that in some cases come up very frequently when we're talking to clients or have an interesting background. So I'll start with the first one, which is, this is really common in all of the industries we work in, the OT space especially, but it's something that's been really prevalent with the buildings, in that you've got a large number of potentially disparate systems, a large number of different vendors. In some cases, those systems are managed by third parties. So when you have this large variety of different types of systems, it can get a little complicated to have effective asset management and asset identification. It can be complicated to make sure that you're watching all of the communication flows, doing proper segmentation, proper zero trust, and especially when there's third-party management and those third parties have remote access, that creates almost a supply chain risk in a way to the facility. Some of the financial institutions that we started working with on building cybersecurity, that was really the initial concern, is that they had third-party organizations that were managing the alarm systems or were managing some of the physical security access. And it was difficult to make sure that they were following basic cybersecurity hygiene, making sure that they were updating firmware, making sure that they were rotating credentials, and making sure that they weren't passing data back and forth among their remote connection that they shouldn't have been. We had a similar example where we found at a hospital, MRI machine transporting personally identifiable information about patients over an FTP connection back to the vendor. That FTP connection was supposed to be for nothing more than firmware updates. But as we watched the traffic, it was very clear that there was data going back to the vendor that included PII and potentially could have been a pretty significant compliance finding on that organization. So making sure that you have a very good visibility, not just into the assets, but especially into the communication flows, seeing what those devices are communicating with, and using that information to lock down those communications, do proper segmentation, and make sure devices aren't talking to things they're not supposed to or sending data they're not supposed to, is a critical part of a cybersecurity program for a building environment. Darryl, that second use case came out of an example that you guys found. Do you want to talk about that one?
Yeah, we were actually doing an assessment. We utilize prior to our managed services being fully deployed, we actually utilize the tool Nozomi as part of our assessment operations, and we were able to find in this one case a small form factor device running some crypto mining in a major piece of real estate in a large portfolio of buildings. It's also very, very telling that these things can be snuck in or even deployed, almost as malware. So having these type of tools running and managing, used to manage the infrastructure is critical. One thing I will add, along with the large number of folks in the buildings and the threats with these different tools, different elements being deployed, kind of clandestinely. One of the elements, and we'll again talk about it when we get to architecture a little bit, is part of our zero trust model does put a wall around the building from a zero trust perspective, and only allows trusted connections to happen. So even if these things are within the infrastructure, we are blocking all outbound communication in conjunction with what we're using, what we're doing with Nozomi. So we're pushing all the data to the cloud for Nozomi, and we're also protecting that perimeter. It's important to have that defense in depth strategy that you're monitoring and also preventing things actively. So that in this case, we were able to inform our customer right away, and their IT department kind of swooped in and did a few things. So yeah, that was it.
Yeah, perfect. Thanks, Darryl. And then the last one there, I think I've talked about this one a lot already, but just using the OT IoT as an entry point to bypass the perimeter security. We've seen this so frequently. We see it even in proof of concept environments. We had an example at a hotel chain that we did a proof of concept for, where within the first 15 minutes, we saw command and control traffic coming from the lighting systems. We've seen examples where the CCTV has been compromised. We pointed out that one earlier with the temperature sensors being compromised. It's just these are stripped down operating systems. There's typically minimal encryption, minimal authentication, and they're not being looked at. So they're very important and sometimes relatively simple targets for attackers who just want to create that presence and use that as a launch pad to try to get to the rest of the organization, whatever those crown jewel devices are that they're trying to get after. If they've got a, pretty, unwatched and easy to infiltrate space that they can do that from, that it creates a much easier scenario for them. So we constantly see OT and IoT used as an entry point to set up a bypass on perimeter security capabilities. All right, so let's get into architecture a little bit and talk a bit about, what the Nozomi Network solution does and how the Intelligent Buildings Managed Service utilizes that to create an offering to help secure these environments. So we'll look at this full attack surface again, this way from a bit of a different perspective. This is, looking at maybe an office environment, kind of in the day in the life of an occupant in a lot of ways, and think about some of the different connected devices that there's potential interaction with from the minute they get there to the minute they leave, right? Just getting to the parking and perimeter, the parking lot, there's often going to be parking sensors, safety cameras, digital displays to pay for the parking, CCTV, in some cases, if it's inside facility, you're already starting to interact with the heating and cooling systems. So even before you've actually, got to the perimeter of the building, the interaction with connected devices has already begun. And when you get into the building, you might have security controls or access controls. You'll have typically a lot of different sensors, the physical security components around card readers or biometric access. You'll have the elevators and escalators. You'll see door card access on both sides of that in some cases. Whether there's a living environment, working environment, you're typically going to have telephony, you're going to have mobile devices, you're going to have lighting, you're going to have, standard networking equipment and printers and things like that. It's just wanted to point out again, and I think, probably talked about this ad nauseum at this point, just as there's a pretty wide array of the types of devices that you're going to run into in that day in the life of working in one of these buildings. It can expand further, and this is something that we find with a lot of our real estate clients and our healthcare clients and our university clients, is that it's typically these projects aren't just the buildings. There's a lot more that can go into a full campus. We've seen environments where there's critical OT components that are a part of that. There's smart grid infrastructure, or potentially even some substation infrastructure. You've got water and wastewater management. So these are all core OT systems. We've seen transportation components at some of them. A lot of the bigger campuses have their own transportation. A lot of the airports that we work with have their own transportation systems. There might be traffic management components, and there might be environmental detection capabilities. If you think about parks, if you think about just streets and alleys, especially physical security and CCTV. We've seen things like air pollution tracking. We've seen things like water pressure tracking. There's a lot that's going out there. And then you have the smart buildings, smart healthcare. So a lot of the projects that we do, they're not individual buildings. They tend to be a campus of buildings with a lot of other infrastructure that makes that campus operate. So it goes beyond just the devices that we'll see on the building side. We look at this from an architecture perspective. Dow, do you want to talk about how the intelligent building systems works for getting all of that data in these environments into the monitoring capabilities?
Yeah, I'd love to. So we do deploy a small form factor, very, very small form factor gateway device, zero trust gateway device. And through that device, we are able to establish that that perimeter around the network as necessary. We can provide secure remote access for those different users, which is important. But more importantly here is we're actually connecting to this building. We're creating an encrypted tunnel, and we're getting that traffic and all of that performance information we were talking about up to a Nozomi Guardian and into their tools rapidly. And we're able to deploy this across large real estate portfolios very quickly. So we're not too hung up on the how their networks are configured or how the systems are working. We're really there to connect to the systems as rapidly as possible and start getting that traffic monitored quickly. So to give a quick example, once our gateways were installed at about a 40 building portfolio across the U.S., so literally from the East Coast to the West Coast and in multiple cities in the middle, we were able to deploy across 43 buildings in a day. And we were able to do that because as we were able to establish that tunnel, standing up the Nozomi Guardian in AWS took minutes. and getting those connections and data flowing to Vantage, again, was really part and parcel of how it worked. And then we run that service for our customers and provide them data and events that are critical to their operations, and we're interfacing with their local teams to make sure that events are taken care of in the real estate environment where maybe staffing is not available to do these things, or there's no internal experts to really react to the different events that are coming out of the Nozomi system. So we really personalize that. We give access to each member of the team locally to the different events, and we push tickets out, and we do all the things we need to do operationally. But it's really about rapid deployment at scale and really quick time to value for different types of customers. So we're excited, and we've been doing this for several years now, and we're having some really good success with different types of commercial buildings. So looking forward to really making sure this keeps moving forward.
Thanks, Darryl. Then to look at it just specifically from the Nozomi perspective, the architecture for these types of environments really isn't that complicated. So whether we have the Nozomi infrastructure in the cloud as described for the intelligent buildings managed service scenario, or if it's more of a hybrid approach where there's Guardian infrastructure in the buildings themselves, it's even if you're looking at it from a scaled out portfolio perspective, typically we can get a significant amount of the data just looking at the core switch, making sure that we've got the VLANs that are responsible for building management, the building networks for the IoT, and we can even look at the IT traffic as well. And in most of these environments we do. So if we just replicate all of the traffic, into a relatively large Guardian appliance, that's where all of the once we see all of the traffic, that's where all of the deep packet inspection will happen. We'll map out the protocols. We'll understand what's in the traffic to do the device identification first. So tell you what devices are there. We'll do the mapping of all of the communication flows. So we'll let you know how each of those devices is communicating with each other, which ones are, communicating outside of their network zone, which ones might be connecting out to the internet. We'll do a variety of different threat detection functionality on that traffic. So we're going to look at indicator-based detections. We're going to look at signature-based detections. We're going to do anomaly detection. So we're going to learn what each of these devices, how each of these devices is communicating, which protocols they're using, how frequently they're communicating, and we'll be able to tell you if we have a camera that's typically just communicating to to other cameras or to the camera control system, and all of a sudden we see it send a bunch of command and control traffic out to the internet, or we see it, hitting a whole bunch of devices all over the place, that'll show up as an anomaly, even if there was no other signature indicator type of detections. So we not only want to make sure that you realize and visualize that entire attack surface of the building, inclusive of all of the IoT and the building management components, but we want to make sure that we're detecting potential threats as they're happening, even if it's something that can't be seen with a signature. So this is a pretty important component. And then to simplify all of this, again, you have a Guardian or some type of capability to replicate the traffic out of each individual building. We get all of that aggregated into a central repository. We can do this at one premises if necessary, but in most cases, back to Darryl's point on the intelligent buildings part, it'll be in the cloud. And using the power of the computing power, the processing power, and just the data storage capabilities of cloud processing, we can do a lot more. We can use our Vantage IQ functionality to kind of act as the analyst and start to pull different pieces of data together and look for where you might get the most bang for your buck as far as investing in certain upgrades or firmware upgrades or patching environments, or just give you an idea of where the most risk is at. We can use asset enrichment functionality to be able to just even use basic information that we've detected passively about the assets to get a lot more information about them, even going as far as in some cases visualizing the asset itself and looking at things like end of life, end of sale, utilization. There's a lot of different functionality we can get there, and then just giving you a single point of contact for looking at all of your vulnerabilities and the threats that we've detected in these environments. So it's a pretty simple setup, and there's a lot that we like to when we go through the implementation process, we get pretty proud of how simple that implementation is, how quickly it scales up, and just how far we can scale up. Our biggest implementation at this point is close to 11 million assets. I don't think we're going to find that in most of these real estate environments. So we can scale to meet any single one of these scenarios. Darryl, anything else to add there before I talk to one of our case studies?
No, I think you hit it. Thank you.
Great. So let's just do this as just a quick look at one of the projects that we've done over the past few years in real estate. So this is one of the largest real estate developers in the world, located in EMEA. Basically, the challenge that they had is that they knew, which is a step ahead of a lot of organizations that we talk to. They knew that they only had a visibility into approximately 30% of their connected devices. They had a gap in being able to detect misconfigurations, and they knew that they had somewhat lax management of the perimeter security, so that there was going to be holes and there was going to be ways to take advantage of those devices that they weren't watching because of the gaps in the perimeter security. They knew that they needed visibility into third-party managed networks and devices, and basically the goal was just they wanted to significantly enhance their cybersecurity posture. They had limited to no visibility whatsoever into connected devices beyond IT and BYOD, so the laptops and cell phones and things like that. They were also facing an increased number of targeted attacks. So this is in a region that was hosting a couple of very high-profile events at the time, and there's some significant geopolitical pressure, and some of the properties that they're operating are seen as very prestigious and indicative of the capabilities of that nation, so that there was some targeting of some of their properties, and they knew that they needed to take the next step from a cybersecurity perspective. So we started this project in the summer of 2022, quickly got up to monitoring the first 80,000 devices. They were only expecting 35 to 40,000, so they knew that they had 30% visibility, and was probably closer to 15 because we found twice as many devices as they were planning to see, because there's a lot that you just don't know about when you start looking at the traffic. We did an integration to set up a workflow in their SOAR solution and their CRM solution, and then basically now that we've done these first few buildings, every quarter, every 2 quarters or so, they continue to add more of their buildings to this monitoring infrastructure. I think overall they've got hundreds of buildings, and we're only starting to scratch the surface of the project here. I think we're doing 15 to 20 of their buildings today out of that several hundred that they operate. But there's already been pretty significant value. They feel like they're getting to the point where they have an understanding of the full attack surface for the buildings that are being monitored, and they're not missing that 70 or more % that they were before. It's been good to have the IoT and building management data available to their security operations team. They did have a very strong security operations team. That capabilities of that team was very good, but they were only able to respond to things they could see, and they were really only looking at the IT data at that point. So being able to get the IoT and the building management data available to their security operations team brought a significant amount of value, and they've been able to make sure that they're going to be able to meet regulatory compliance as there's new standards coming for that region that have to do with cybersecurity for their industries and the industries of some of their clients that are operating within their buildings. It's a relatively simple implementation solution-wise. We used 7 of our largest Guardian appliances, which is mostly NSGM, across the first 3 properties. So that was just the first components of it there. 4 CMCs, they'll move to Vantage in the very near future. It just wasn't available in that region at the time we started the project, and using ARC and remote collectors as needed to be able to get additional data from smaller locations, branch office type of locations, things like that. So this was a very successful project in the real estate space. We've got plenty of others. So if any of you want to hear more about this project, or potentially talk to this client, or you want to hear more about some of the other projects that we're doing, you can reach out to me on that. And then Darryl, I know that you've got a lot of examples of customers that are using the Nozomi solution as well. Do you want to talk to any of those beyond what you already have?
Well, just add a couple of a little bit different scale. Obviously, this was a huge one, but as we were in some of the real estate assets we've seen, and especially as troubles in Europe came about last year, we were seeing an increased set of attacks from a malware perspective, and we were monitoring some really troublesome traffic. And these are at commercial buildings in the U.S., and we're talking about systems like the building automation system, the HVAC system within office buildings. Now these are Class A assets that we're talking about, but they're still just the run-of-the-mill system. And when we were monitoring these things and finding them utilizing Nozomi to identify the threat, and we were able to capture the traffic, and we were able to work with different authorities to make sure that the attack was well documented. For us, as we were looking at this, is no building is really innocuous, right? That these threats do crop up because I started to mention earlier, the number of users that touch the real estate assets is surprisingly large, and it's kind of one of those as these untrusted devices get access to trusted networks and trusted devices, there has to be that monitoring component. You need to put other elements in place from a defense in depth perspective, but you have to monitor them to make sure that these things are really being handled appropriately. We're finding anomalies, and we're able to stop the threat before it causes a problem. And with what Nozomi was able to do for us in that instance, as we were able to, again, work with that customer, work with federal authorities in the U.S. to provide the data they needed to again track the threat and properly document it. So it spans a different systems, different scales. But like I said, there's no system that is really safe because of the pure number of devices, as I think you mentioned in the beginning, that the number of devices and everything is becoming everything everywhere is connected. And the number of times as we walk in a building that there are either unknown devices, Raspberry Pi on the 15th floor that nobody knew the function of, or just the pure number of different connections and number of egress points for those devices to get out. They have multiple points of exit and entry, and typically not very, at least in the systems we see in the building systems world, sometimes networks that aren't as robust as anybody, or even, I wouldn't even say not robust, they may be just under designed and old by today's standards. So there are things that we are doing in our service to start mitigating those issues. So.
Perfect. Thanks, Darryl. So I think we're starting to get some Q&A now that we're towards the end of the presentation. Darryl, I don't know if you can see that, or if it'd be easier for me to read this. But you can. Okay. So
yeah.
Want to take that?
So in the first question, that it was, thank you for sharing. How many gateways did you need per property? Now, our gateway is able to handle, a large number of devices. In the cases of our typical real estate deployment, we have one gateway per building, and we converge the different BMS networks on that one gateway. If the network is managed and we can get multiple VLANs through it, it's very simple. But we also have multiple physical connections that can be made. So our typical deployment is one. There are some larger deployments because of the physical architecture of the site that we've had to put two in place to get the same effect. Do you need a gateway per network? I think I answered that, but I'll make sure it's clear. Per network in a situation where there are multiple OT, IoT networks, no, our device can span those networks, and we can merge those different networks into one stream to the Guardian in the cloud. Because typically what we do is one Guardian per building and one gateway per building, and we get all that traffic, and we're parsing it out at the Guardian level. And the third question, identify, how are you able to identify any clandestine networks? So what, and Michael, you can help me with this a little bit. Part of what Nozomi is able to do is it's in there for the long haul. So we're listening 24/7. So when we have, what we've done in the past is, even if you just were listening at noon on a Thursday during an assessment, you might not capture every typical OT device because it might not have talked during that time, because some of these devices aren't big talkers. So if you're just listening, like doing a PCAP, if you're just capturing traffic on an afternoon to see what's going on, you might not see anything. But the fact that Nozomi's on 24/7, listening to all the traffic, analyzing that traffic, those devices, the moment they make a peep, we can see them and then start analyzing them. So I think the main point there is in kind of the default configuration through that pure passive mode, we can do a lot. And I do know, and maybe Michael would be better to talk about this, there are the ability to talk to turn on some very specific protocol-based active queries and inject that into the network as well to start learning a little bit more about what's going on. And that's also another method that can be used depending on what we're listening for.
Yeah, I think you answered that pretty well. I think, just on that last point on the clandestine networks, of course, it depends on what's actually going into the span, what we're actually seeing, right? But as long as we're seeing the traffic, we're going to be looking at communications in and out of the zones that we're monitoring. And if there's a network out there that shouldn't be, and we do find these a lot, actually, you will typically see some type of communication going in or out of that network. Or we'll see attempts for that network to communicate out to the internet. We'll see something that will be indicative of, devices out there, networks out there that just don't belong. We saw a recent example. We did an implementation at a luxury goods manufacturer here in Central Europe, where they had a robotics line replaced and didn't realize for weeks that the new robotics line actually came with its own LoRaWAN network, and that LoRaWAN network was collecting data from different parts of the line, and the manufacturer, the OEM, was utilizing that LoRaWAN network, but they weren't even aware it was there. But it was because some of those devices started communicating on the wire in ways that we could see them, we were able to alert that client that we saw that happening. We've seen it even in OT networks where the OEM has set up a wireless access point or some type of network equipment to set their own networks up. This is a pretty common thing, but it's of course dependent on, we have to see something, we have to see the traffic. If it's a completely clandestine network that's not connected to anything and just communicating with each other, if we don't see that traffic, we may miss it. But that's the most important part of it. But if we're seeing the traffic, we're going to be able to identify it and find it for you. So I think, Darryl, I think this next question is targeted for you as well.
Sure.
Around Somalia.
So yeah, thank you, Will. This is from Will. What is the commercial model for the service? Is the device installation and monitoring lower cost than the remediation service, or is something different? So I'll just explain how our model works, and I'll see if I can make sure I answer that question. The way our model works is we bundle the solution with a certain amount of remediation assumed, and we also embed in some of our services kind of a fractional FTE to be part of a team. So that would be kind of a parallel service. So as we get into more and more complex deployments, large real estate portfolios that we really do require a little bit more remediation work, we do have a separate approach with our kind of that fractional FTE. But embedded in the core service, we are responding and communicating to local teams and our customer to make them aware of the service. It's an embedded as kind of a one-stop shop, so to speak. So we do. Let me make sure I'm making sure I'm answering this. I'm rereading it. Is the device installation monitoring lower cost than remediation? I would say, since I kind of build a certain amount of that into it, knowing that every building's going to have events that are happening over time. So it's really not a two-pronged approach. We put it all together in one managed service. Hopefully, Will, that answered it. Thank you.
Yep, that's clear. Great. All right. Do we have any more questions from the group? Otherwise, Darryl, any closing thoughts?
I appreciate the opportunity. So we've been at a number of years as an advisory services firm for about 20 years, and working through managed services for about the last 6 or 8. And we do specialize in real estate, and we do see that multiple teams have a hard time necessarily putting together necessary horsepower or justifying resources. And that's one of the reasons we think the managed service approach, again with Nozomi being an MSSP, and allows our customers to take advantage of more of a defense in depth approach, where we can secure the network, we can monitor the network, and we can do other things. And And with the Nozomi tools and capability, and honestly, the amount of research they're doing constantly with different OT vendors, that they're in their labs and they're constantly providing more and more data. We can see model numbers and we can see firmware versions, and the growing number of things we're identifying and able to provide back to our customer. I think it's been very telling, and that the industry, I think, needs something along these lines. One thing that I'll also say is one of the primary use cases that really gets the attention of a lot of people in the real estate world is really the idea of asset inventory, not just the monitoring, that's important, but in the world today where we're seeing a lot of distressed assets getting sold and bought, especially with the potential commercial real estate financial crisis that's happening. Knowing what's in your building is extremely important, and understanding how the systems are architected, how the things are communicating, and putting in that defense in depth. Sorry for repeating that, but the strategy around securing your networks, monitoring your networks, and all of the OT and IT devices, IoT devices that are in the building, I think is a foundational strategy for a lot of people, because as they take over these assets, reducing risks and reducing insurance premiums and other things that we're seeing when these strategies get implemented, I think is an important fact to keep in mind. So appreciate the time today. Appreciate everybody's attention and the good questions. So thank you very much.
Yeah, same. I appreciate everybody being able to join.